In this lesson, we're going to learn how to graph linear functions given a table of values using slope-intercept form and also using our intercepts. We will also take a look at some word problems where we have to give realistic constraints on the domain and range. The three methods, like I said, that we're going to use to graph linear functions is given a table of values using slope-intercept form and the intercepts method. When we use slope-intercept method, we just need to make sure that it's in the right form. Y equals mx plus b. We have to make sure that the y is isolated. And then we're going to plot the y-intercept and then use the slope rise over run to locate at least one other point. Then we will draw a line through the points and put arrows on the ends. So let's get started. Again, we're going to first use slope-intercept method to graph our linear equation. We have 2x minus 3y equals 12. Let's remind ourselves of what slope-intercept form is. It is when we have y isolated. So in this example, we need to get the 2x term off of the left side, so we are going to subtract 2x from both sides. I'm going to be careful when I bring down the 3y that we notice it's negative 3y. Then I'm going to put my x term first. And now we simply need to divide each term by the coefficient negative 3. This gives us y equals, when we have a negative divided by a negative, that's positive. So our slope is positive 2 over 3 times x. And then our y-intercept is going to be minus 4. So let's identify my slope and the y-intercept in the form of an ordered pair. Now, let's graph this. We're going to start with our y-intercept, where the point of where our graph crosses the y-axis. So it's 0, negative 4. Then we're going to use the slope, rise 2, run 3. So we're going to go up 1, 2, and to the right, 1, 2, 3. Plot a point. 2 points is all we need for a line, but we can go ahead and plot another one. We can go up 1, 2, and to the right, 1, 2, 3. Now, sometimes we're given a graph where we can't plot another point, not enough of the coordinate plane is given. So let me show you what you would do in that case. So our slope is up 2 and right 3. Well, let me show you how you can totally reverse this. So if this is our y-intercept, instead of going up and right, we can do the total opposite, and it's the same. We can go down 2 and left 1, 2, 3. And you can see it falls in line with our linear function. Now, let's state the key features. Our domain, we have arrows on the ends, even though they're not on here, they're really just always take it that there are arrows on the ends of our graph unless we have endpoints shown. So the domain, our x values continue forever left and right. We can use any x value for this function. This function can also take on any y value, so we have all real numbers. This graph crosses the x-intercept at 6, 0. Now the intercepts are ordered pairs. My domain and range here are intervals. The y-intercept is going to be when x is 0, 0, negative 4. My interval of increasing, again, this is an interval. So we're going to use parentheses. So my graph is increasing across all the x's. The x's are causing my graph to increase, and it never decreases. So all real numbers. And a linear function is going to either increase, decrease, or remain constant if it is horizontal. So we're going to use the null symbol to indicate that this graph never decreases. There are no x values that will cause the graph to decrease. Now let's do end behavior. As x approaches negative infinity, as we go left on the graph, the end of the graph approaches negative infinity. Then, as x approaches positive infinity, as our x values increase, our y values increase. So f of x approaches positive infinity. So it's just telling what the end of the graph looks like on the left side and what the end of the graph looks like on the right side. That is end behavior. Let's do one more example using slope-intercept form. Again, let's remind ourselves of what the form looks like. We're going to subtract 3x from both sides. This gives us positive 4y equals negative 3x minus 4. We're going to divide by our coefficient 4. And we have y is equal to negative 3 over 4 times x minus 1. Our slope is negative 3 over 4. Our y-intercept is 0, negative 1. Now let's plot this. We're going to start with the y-intercept, our starting point, 0, negative 1. This time our slope is negative, so we're going to go down 1, 2, 3, and to the right, 1, 2, 3, 4. 1, 2, 3, 1, 2, 3, 4. Now, we know our slope is negative and it's sloping down and we're correct, but let's use the method just to practice to go the exact opposite. So instead of going down 3, right 4, let's go up 3, left 4. 1, 2, start over. 1, 2, 3, and left 1, 2, 3, 4. And you see it lines up. And then we'll draw a line all the way through as neatly as we can. Arrows on the end. Let's do our key features. This graph takes on all x values. Any x can be put into our function, and then the graph extends all the way down and all the way up, so our outputs are all real numbers. My y and x-intercepts are ordered pairs, and this x-intercept looks like, and we can just estimate this, and so it looks like it's negative 1. I'm going to say negative 1 point, we'll say 3. It's not quite 1.5, or maybe it is, so we can just estimate it, comma 0. You know, actually, guys, this is a great little teaching moment. Since we have the equation, let's just see exactly what it is. So the x-intercept is when y is 0. So let's plug it into the equation. Let's isolate the x. And now let's multiply by the reciprocal, negative 4 over 3. X equals negative 4 over 3. I should put parentheses right there. So it's negative 4 over 3 times 1, and we get negative 4 over 3. Since we are graphing, I'm actually going to convert it to mixed. I'm only converting it to mixed because I'm trying to locate this. So that's going to be negative 1 and 1/3. Oh, I was pretty close because 1/3 is 0.3 repeating. Very nice. Okay, very good teaching moment there. If you are given the equation and it's hard to see, if you're given a graph and the equation and the intercept doesn't land exactly at a nice point, like an integer, then you plug in 0 for that opposite coordinate and do your algebra. My y-intercept is going to be 0, negative 1. This graph, reading left to right, we can see that it's decreasing and never increasing. So let's use the null symbol. It decreases from negative infinity to positive infinity. The left side of the graph, so as x approaches negative infinity, here's our negative infinity and our positive. And then we have a positive infinity up here and a negative infinity down here. I like to put those on the graphs. It really helps see. So as our x values decrease, as we go toward negative infinity, the end of the graph, the outputs are increasing. So f of x approaches positive infinity. So as we go left on the graph goes up. Now let's describe the right side. As x approaches positive, excuse me, positive infinity, as the x values increase, the outputs actually decrease. They go down on the ends. Okay, now let's take a look at the intercepts method. Like we just saw, once you plug in 0 for x, you will find the y-intercept. Or if you want to find the x-intercept, you plug in 0 for y, and then we do the math. 2 points is all it takes. So if we know the x and y-intercepts, we really can create our linear graph. But sometimes you may want to take a look at a third point. Remember when we studied about standard form? This is one of the benefits of standard form is the intercepts method. So let's see how this works. So if we want to find the x-intercept where it crosses the x-axis, we're going to plug in 0 for y because to be on the x-axis, we can't have any vertical change. We can't go up or down. So that's why the y needs to be 0. So you can see this is in standard form, and we plug in 0 for y, we end up with just 2x equals 12 because 3 times 0 is 0. Then we just have a simple equation to solve, and we get x is 6. So 0, 6 is our x-intercept. Then if we want to find the y-intercept, that is where x is 0, we plug in 0 for x, and we have a simple equation, 3y equals 12. And we simply have to divide by the coefficient, and y equals 4. So we have 0, 4. Now, if we want, we can pick a third point. So I'm going to just pick a number between the 0 and the 6, and I'm going to pick 3. I kind of look at my equation to see if it comes out as a nice, neat integer. So when x is 3, I would get 2 times 3 is 6. And then when I subtract 6 from 12, I get 6, and I know 3 can divide into 6. So let's work that out. So we have 2 times, so I'm going to plug in 3 for x. We subtract 6 from each side. We divide by the 3, and we get out y is 2. So 3, 2. And then we will draw a nice, neat, straight line with arrows on the ends extending all the way. And now let's take a look at the key features. Our line extends left and right. We can go, our range, we can go all the way down and then all the way up. Our x-intercept, we just saw those. So the x-intercept is going to be 6, 0. Our y-intercept is 0, 4. This graph has a negative slope. It is sloping down, so there are no x values to cause it to increase, and it decreases across the graph. Now let's pencil in these arrows that are understood here. So as x approaches negative infinity, f of x goes up, approaches positive infinity. And the right side of the graph, as x approaches positive infinity, f of x is going down, approaches negative infinity. Okay, let's do one more. Again, we're going to plug in our 0 for y to find the x-intercept. And we have negative 4x equals negative 8. We divide by the negative 4 on both sides, and the x-intercept is positive 2. So 2, 0. Now let's plug in 0 for x, and we are left with 2y equals negative 8. We divide by the 2, and my output value is negative 4. So 0, negative 4. So we have a positive line Okay, let's see if we were to put in 1 for x. I believe that's going to work. If we put in 1, we're going to get -4. And then if we add -4 to the -8, we get -4, and 2 can go into that. So I always want this coefficient to divide into our constant. So after we do the math here. So let's put in a 1 for x. So that gives me -4 times 1 is -4 plus 2y is -8. We're going to add 4 to both sides. We're going to divide by 2 and get -2. So 1 comma -2 is a point, and we see it does line up. So now if your equation is in slope-intercept form, y equals mx plus b, you definitely want to use that method. If it's in standard form, you can try to use the intercepts method. Let's do the key features. Negative infinity to positive infinity, negative infinity to positive infinity. That means this graph continues left and right and down and up. My x-intercepts we just found. So the x-intercept is 2, 0, and y, -4. And this increases and it never decreases. It's constantly, as we go from left to right, our graph is going up. And then null for decreasing, it never decreases. As x approaches negative infinity, f of x approaches negative infinity. There are arrows on the ends of these graphs. And on the left side, which means negative infinity, as x goes negative infinity, that's the left side, it goes down. Then as x approaches positive infinity on the right side of the graph, the right side of the graph is going up. Now let's do one example. You have done this probably a few years ago, but you can always fall back on this. If you have an equation, you can simply create a table of values. I always like to pick some negative values, the 0 value, and positive values. So most of the time, depending on my equation and how it would work out, these are the values I use. So I'm going to find 5 points. Again, you can always use this method. It may take a little bit longer, but if in the end you forget how to use the other methods, this will always work. So I'm going to plug in -2 in for x, and I'm going to be very careful. So I have my negative from my function, and then I'm going to plug in -2. So a negative times a negative is positive. So I have 2 plus 3 gives me 5. Then I'm going to plug in -1. This gives me +1 plus 3 gives me 4. I'm going to plug in 0. I'm going to plug in 1. And I'm going to plug in 2. Now let's plot these points. So I have -2, 5. I have -1, 4, 0, 3, 1, 2, and 2, 1. Now, to be efficient, we really would just use the slope-intercept method and plotting 0, 3 and using our slope down 1, right 1, down 1, right 1. But again, if all else fails, you can always revert back to this for any equation. The domain is all real numbers. My range is all real numbers. The x-intercept is going through, looks like 3, 0. My y-intercept was 0, 3. This is never this is never increasing, it is decreasing. On the left side, my end is going up. On the right side, my end is going down. So as x approaches negative infinity, this way here, f of x approaches positive infinity up here. Then as x approaches positive infinity, this way, f of x approaches negative infinity. It is going down.